Hello and welcome to our Expert Insight video series. I'm Chitra Sethi, Editorial Director at SAE Media Group. Simulation has long been a critical tool for engineers, but today simulation apps are transforming who can use it and how decisions get made across organizations. By packaging advanced multiphysics models into easy to use, intuitive applications, simulation is moving beyond specialists and into the hands of engineers and business leaders, enabling faster, more informed decisions in real time. In this Expert Insight interview, we are joined by Björn Sjödin, Senior Vice President of Product Management at COMSOL, to discuss how simulation apps are reshaping engineering workflows and turning physics-based insights into strategic business value. Welcome, Björn.
Thank you for having me.
So let's get started. Beyond simulation apps are shifting modeling from a validation step to an early decision making tool. How does that change the way products are designed from day one?
Yeah, simulation apps change the design process by bringing physics modeling in much earlier. So instead of waiting until later to validate the design, a simulation app makes it possible for teams to use this technology very early to explore ideas, to make design change, to see how they impact the design. And perhaps even more important is that more people can be involved in the whole design process, not just simulation experts, but it can also include designers, product teams, manufacturing teams, even sales and marketing teams. And we see that simulation apps really makes it easier to collaborate between these different teams.
And you mentioned more people getting involved. Why is it important now to allow designers and engineers across disciplines to use simulation apps directly into their workflows?
Yeah, product design cycles get shorter and shorter, and there's less room for mistakes. There is a lot of expectations on not making mistakes. And if you have an idea that doesn't pan out, it can delay your product release, especially if there are shortcomings that you don't detect early, you detect them too late. Then simulation apps makes it possible to involve all the different teams and decision makers at an early stage in the development of a new product, or it could even be a process. And you have decisions to be made with respect to materials, geometry, thermal performance, structural performance, manufacturability, cost sustainability, and so on. And when people from these different teams and disciplines can work with simulation apps on their own time, they can test ideas sooner, they can understand trade-offs, make these decisions in the right context. And you get faster development, you speed up the design iteration cycle, and you get simulation technology to be part of the everyday decision making, not as a separate step as the end when it's too late, perhaps. And then another important aspect that sometimes is forgotten is that it takes time to train people on expert level simulation tools. There may not be enough time allotted in a project to train using these expert tools. And simulation apps completely or near completely avoids this, since the simulation apps have been designed by your organization to be easy enough to use that no software training is needed. It speaks the correct terminology for the application at hand, and the user interface is very easy.
Great. The surrogate models and reduced modeling are central to making these apps fast and accessible. How do these techniques transform what's possible in real time design exploration?
Yeah, this is something that is very exciting. Surrogate modeling techniques weren't so developed when we first released the application builder that is used in COMSOL multiphysics to create apps. But surrogate models can be game changing when it comes to simulation apps, because even though simulation experts can have the time and patience to wait for a simulation to complete, maybe it will take 1 minute, 50 minutes, 1 hour, 1 day. But people in other positions and in other teams, they may not have the patience, they may not have the time to wait for this. You need sort of near instantaneous feedback. And this is what surrogate models can give you. A trained surrogate model is kind of a pre-compiled version of the physics model or physics simulation, and it can give you this instantaneous feedback. You can, for example, drag a slider in the user interface and see the results update live. Surrogate models is kind of a perfect fit for simulation apps, because already from the get-go, when you train the simulation apps, when you train the surrogate model, you limit the inputs into certain brackets, certain intervals. And that is something you have to do on the simulation app side as well, because you want to work with a validated model. So surrogate models in simulation apps give you this instantaneous feedback, and it gives a possibility to have a workflow in the simulation app that will encourage things like, what happens if we change this parameter? What happens if we change that? So it supports experimentation in a way that you wouldn't see if you have to wait for 50 minutes, an hour for a simulation to complete. And that's the real value of surrogate models, fast evaluation.
Got it. And Björn, you have seen these tools used in real engineering settings. Can you point to a real world example where simulation apps clearly delivered measurable benefits for engineers?
Yes, we have a number of use cases or user stories that we have written about over the years, how simulation apps are being used in industry. One case that I was thinking of is Mahindra from India in the automotive industry. They use the application builder in COMSOL to develop simulation apps for structural and NVH analysis of components in automotive settings like stabilizer bars, engine mounts, chassis concepts like frames. And they used the application builder, COMSOL compiler, and COMSOL server to deploy these simulation apps throughout their organization. And this allowed these conceptual designs to be experimented with and shared and evaluated much earlier. And the number of design iterations reduced drastically. And this can be even before the CAD model is ready. So you can do this at a very early stage when you only have the frames, for example, represented by beams. Further downstream, when you create a CAD model, you would, of course, have the profiles of the beams, but you can make simplified model, conceptual models early in a simulation app. And this allows other teams than the CAE experts to experiment, while the CAE team can focus on other tasks. Now, CAE teams is frequently a bottleneck in R&D and development organizations, since if there is an issue found downstreams in the product development process, the request needs to go back to the CAE team, but they may have other things to do. They may have a queue of jobs they have to run. So then these teams have to wait for the runs, they wait for the CAE team to have time allocated. And this can be a real bottleneck, and simulation apps can completely short circuit that bottleneck. Another case I wanted to mention quickly is Graphtec, and this is a company that manufactures graphite electrodes for the steel industry. And at Graphtec, simulation apps has even been used in sales and marketing in conversations with customers. So the customer may have some specification changes they want to make, and these simulation apps makes it possible to see the performance impact of those specification changes in a conversation with the customer at this sales stage. And that is quite impressive, and it helps building trust with the customer, of course.
And you mentioned speed earlier and accessibility too. These are often framed as benefits, but what risks come with simplifying complex physics into app-based tools, and how is COMSOL addressing those risks?
Yeah, there's always this fear of, if I don't put in valid inputs, then I will have garbage outputs. So what if a user enters unrealistic inputs and the model gets applied to the wrong problem? You can end up with having false confidence in the model. But this is the beauty of simulation apps, because they are built on top of a validated physics model built by a simulation expert. And this simulation expert decides what inputs and what outputs should be exposed to the user. And the expert then validates the model for a certain set of input parameters. You typically have a max and min value for each parameter, and the expert has validated the model thoroughly for these values. So there's always risk involved in simulation, of course. You might get the wrong answer, but if you have a well-crafted model and a well-crafted app, then this dramatically reduces risks, perhaps all the way to zero in some cases. So in short, I would say safe inputs give you safe outputs, and that's how it's handled in simulation apps.
Thanks. And in which industries are you seeing these simulation apps being adopted the most? And also related to that, are all of these custom apps?
Yeah, that's one of our favorite questions. So these apps are always custom apps. They're typically built by some core technology team in an organization, and they sort of encode the most proprietary knowledge in an organization. So typically, we don't see all these apps that are being created out there in different organizations, but they are quite exciting. And when we get to see them, and when we get to write about them, we write about them in stories on our website. So I encourage you to read up on that. The but what's nice is that there is not the particular industry where we see simulation apps being more important, but this goes across industry. Wherever there's a need for simulation, there is also a need for simulation apps, because again, you have these bottlenecks with the CAE team, with simulation experts. They have finite resources. They can't do all the simulations that may be requested. So we see simulation apps being used in automotive industry, traditional manufacturing industry, aerospace, medical technologies, semiconductor manufacturing, construction, energy, even food industry. We have some great user stories from food industry. So the need and use of simulation apps is quite general, and is used throughout the industry in general, I would say.
Great. And looking ahead, Bjorn, do you think simulation apps aren't just a trend, but a foundational shift in how modeling and design will be done over the next decade or so?
Yeah, we think this is a foundational shift, and there are a number of different technology advances that has made this possible. We mentioned surrogate modeling. We also have GPU accelerated solvers that makes this possible, AI, and so on. And what's changing is the simulation is no longer expected to stay in the hands of a few simulation experts, and is no longer something that is happening very late in the process, but these validations and experimentations are expected to take place throughout the whole design cycle. So you expect to be able to use simulation continuously, and this is what simulation apps make possible. From like early concept through testing, manufacturing, and as we mentioned earlier, even sales and marketing. And once an organization starts working that way, it's very hard to go back, because this value is not only in speed, but it's also the decision-making process becomes more efficient. You get decision-making possibilities all the way throughout, not just at a later stage. So over the next decade, I think simulation apps will become a core part of how engineering is done, and not just some extra thing you do at the end of the design cycle.
Excellent. Well, thank you so much for your insights, Bjorn, and for joining us today.
My pleasure.